1.5 kilometers beneath the surface of the Red Sea, the water stops behaving like a single body. Down here, a distinct, heavy lake sits undisturbed on the ocean floor. This submerged lake has its own shoreline and visible waves, covered by a thick fluid that hovers over the surface like a ghostly fog. But this shoreline is a mass grave. The entire perimeter is littered with the corpses of crabs and eels that died decades ago, yet remain perfectly preserved without a trace of rot. The lack of decay reveals the true nature of this place. It is a functioning, lethal trap, maintaining its victims in a state of permanent, eerie suspension. The water inside this pool is 8 times saltier than the surrounding ocean, creating a toxic environment. For most marine life, touching this water triggers immediate toxic shock. Cells rupture and muscle spasm as the nervous system is overwhelmed by the salt concentration. The fluid is so dense that it behaves like a physical barrier. If a multi-ton research submarine attempts to enter, the hull will bounce off the surface like it hit a trampoline. This cross-section diagram shows dense salt sinking into an ocean floor crater. Normally, these particulates dissolve, but geothermal heat creates upward arrows that push against the sinking salt. Hot water rises while heavy salt is forced down, creating a sharp, turbulent line between layers. The result is a mirror-like surface that acts as a physics. Just inches away from this lethal boundary, a bizarre world of scavengers exists. Pale fish navigate through towering, alien-like tube worms that emerge from the dark, jagged rocks. This dense colony of large mussels has survived on the shoreline for over a century, providing a home for pale crabs and shrimp that crawl over the shells like insects. These shrimp wait at the absolute edge of the brine. When a fish breaches the toxic water and begins to spasm, the shrimp dart forward, grabbing the prey and pulling it back to safety before the poison can claim them as well. The ecosystem's most specialized inhabitant is the hagfish. This smooth, grayish-purple creature is the only living thing known to dive directly into the deadly brine to hunt and return to the surface alive. This entire food web has evolved to weaponize a hazard. They use the toxic pool as a permanent hunting ground, thriving on the victims the brine claims every day. To remain lethal, this pool needs a constant supply of heavy salt to replace what slowly escapes. That supply is fueled by a geological engine deep beneath the crust. This timeline shows a Jurassic Ocean drying up 180 million years ago. It left behind a massive bed of white salt that was eventually buried under miles of rock and sediment. Today, seawater seeping downward through cracks in the crust hits that ancient salt bed. The Earth's internal heat boils the mixture, forcing it back up to the ocean floor as a continuous, dense waterfall of brine. This provides the salt, but it doesn't explain how these creatures survive in total darkness. Without sunlight, the standard rules of biology don't apply. These organisms rely on chemosynthesis. Bacteria living inside them consume the lethal methane gas bubbling from the lake and convert that poison into usable chemical energy. The entire system is a self-sustaining loop. It is powered by ancient geological salt and toxic gas, rather than the energy of the sun. This isolated graveyard is actually a window into the most violent chapters of our own history. 3.5 billion years ago, Earth was an oxygen-starved world. The oceans were dark, incredibly salty, and thick with methane gas. Current models of the early Earth suggest life began within the crushing pressure of these toxic brine lakes, thriving on chemical energy long before the first organisms reached the sunlit surface. Our most distant ancestors were born and forged in an environment of absolute lethal toxicity. If biology can thrive on chemicals in the dark, we have to expand where we look for life in our solar system. The fractured, icy surface of Jupiter's moon, Europa, hides a massive, dark ocean. Like our own brine pools, it is rich in salts and complex chemicals. Saturn's moon Enceladus also hosts a sunless ocean, trapped beneath a thick, frozen crust, providing a similar environment for chemical life. This is why NASA is launching the Europa Clipper mission. They are sending hardware into deep space to search for the specific chemical signatures that indicate life is active beneath the ice. The mechanisms that allow life to persist in these deep-sea graveyards provide the criteria NASA now uses to scan for activity in the farthest reaches of our solar system.